What's up, everyone? Today we're going to talk about linear correlation and Pearson's product moment correlation coefficients. So let's get into it. So first, just some front loading of data and correlation in general. Bivariate data has two variables, hence the prefix bi, whereas univariate data only has one variable. With bivariate data, you are often comparing to see whether there's any correlation between two variables. And that's what we're going to focus on first. So we got three main types of correlation. We have positive correlation, we have negative correlation, and then we also just have no correlation. And you can tell graphically whether it's positive, negative, or none just based on the trend of the data points. If it goes up, it's positive. If it goes down, it's negative. If there's no real, you can't really tell, that's when there's no correlation. We can also define the type of correlation by how strong that correlation looks. The tighter the data values are together in terms of a line, we're going to have a strong correlation. If they still form a pretty good line, but they're a little bit more spaced out, we'd say that's moderate correlation. And if you see that there's still, like in this case, it still looks like a positive correlation, but they're really spaced out, that's when it's a weak correlation. All right, so let's get into an example. 12 students took tests in English and in math. The results are shown in the table below. We first are asked to plot the points on a scatter diagram and sketch it below. So if you want to plot it on your calculator and then just transfer the sketch over to here, or if you want to take the time to really scale things out and plot them accurately, you can do that as well. To create your scatter plot in your calculator, first go to Stat and Edit and enter in your X and Y values to L1 and L2 respectively. This is for example 1. Then you got to do a couple different things. First, go to Y equals. If you have anything in there, clear it out. You can either automatically just turn on plot 1 here by going up and pressing enter, or if you're not sure what type of plot it's going to turn on, you can press second and Y equals, and it'll show you that mine is set to be a scatter plot. If it doesn't have the scatter plot, hit enter, and just make sure you choose it from here. You can also create histograms, you can create box plots, modified box plots. You got a lot of different options in here. If you hit graph, depending on how your graph is set up, you might be able to see a couple points, but in order to make sure the window fits your information, go to zoom and go down to zoom stat number 9. This will take whatever you have in your list and automatically change your window accordingly. So we can tell even from here that we don't have much of a trend here at all. All right, so here's my scatter diagram. I kind of scaled it and eyeballed it at the same time. So looking at my scatter diagram, letter B, we're asked to describe the correlation. Whether it's a sketch here or on your calculator, it really doesn't look like there's any correlation. You can't really tell if there's a positive trend or a negative trend. And if you can't tell that, that's when you have to say there's no correlation. And part C, state whether you think that a grade for the English test has an influence on the grade for the math test or the mathematics test. So when you're looking at correlation, you're looking to see if they're correlated, if they're related. This is asking if you think that English influences math. So does a grade on one test cause the grade for the other test? We'd have to say no. And that's regardless of no correlation or correlation. We don't know that the English test grade affects the math test grade. So you could say something along the lines of, no, a grade in English doesn't cause a certain grade in math. And I'm saying it that way just because I put English on my x-axis and math on my y-axis. All right, so that's just using the graph itself, right? We learned in Algebra 2 about the correlation coefficient R. So we're going to talk a little bit more about that now. Its full name is Pearson's product moment correlation coefficient, but it is still represented by that lowercase r. So while there are several ways to classify the strength of a correlation numerically, one of them is this Pearson's product moment correlation coefficient, or R, or we'll abbreviate it to just PMCC sometimes. R is a measure of linear correlation, very specific, between two variables, and it can take on values between -1 to 1 inclusive. A correlation of -1 means that it's perfectly negatively correlated. A correlation of +1 means that it's perfectly positively correlated. A couple things to note when finding R. The order of the variables is not important, so you don't have to make sure they're in like increasing order or anything. The correlation coefficient itself has no units. In exams, you will only be expected to find the value of R using technology, meaning using your calculator. There is a long way to find it by hand, but in terms of our exams, that's all you'll need to know is how to find it in your calculator. And R represents correlation only, not causation. So just like we were just talking about with the math and English test, that they could have been correlated, but that doesn't mean that one causes the other. All right, in example 2, this table gives the test results in mathematics and biology this time for 8 students. And in part A, we're again asked to plot the data points on a set of axes and sketch it below. So same kind of deal. If you want to do it in your calculator and just transfer the sketch over here, or if you want to scale this out a little bit, knowing what's coming, I would at least be a little bit more accurate than just doing a bunch of dots in between those axes. All right, so I put my math on my x-axis, biology on the y-axis, and I have this scatter plot, again, somewhat eyeballed. Part B asks you to comment on any correlation you see on the graph. So again, not finding R yet, just looking at the graph and commenting on the correlation you might see. So in this case, it does look like there's a positive trend. This one kind of throws things off, or else I'd say it's strong. So I'm going to say positive and moderate. But in part C, we're asked to actually find Pearson's product moment correlation coefficient for this data and then compare it to our answer in part B. To find the correlation coefficient, go back to Stat, over to Calc, and we're going to use linreg in order to find it. Make sure your X list is L1, your Y list is L2. You do not need a frequency list, and you don't need to store it anywhere. Just go down to calculate. If your calculator is like mine and it doesn't give you an R or an R squared value, you can do two things. Depending on your calculator, you can go to Mode and down to Stat Diagnostics and turn it on. Or if you don't have this menu option, you can go to Second and 0 to go into the catalog, find Diagnostics. You can either just press the down arrow or it is alphabetical. You can just hit D to get there faster. Diagnostic on, enter, and it'll turn it on. Now when I go into my linreg and calculate it, it gives me my R. We're looking at R here for our correlation coefficient, not R squared. So we get R equals 0.864, which definitely goes along with the positiveness because it is a positive number, and it's pretty moderate. In general, and there's no like necessarily hard and fast rule for it, in general, we'd probably say anything over like a 0.85 or a 0.9 would be strong. Anything between like a 0.5 and a 0.75 or a 0.8 would be moderate, and then anything less than 0.5 would be weak.